So I've just created two beakers containing a bromocresol green solution in DI water. I didn't really measure the concentration, I just squirted a little bit of the indicator into the beaker, and I'm about to pH adjust them. One fun fact, the bromocresol green indicator, you guys can see this here, appears to be received in 1979, making it older than me. Okay, so I've got my two beakers of bromocresol green in solution. I didn't measure the concentration, I really just added in a squirt of the bromocresol green and into DI water. And starting off at a pH around 6. So this beaker on the right, I'm going to lower the pH to below 2, forcing it down with 1 molar HCl. So we can see it's gone from a bluish color to a yellowish color, and my pH is close to pH 2. I guess I won't force it down all the way. My other beaker I actually already added some sodium hydroxide to, so that blue color is maintained at high pHs, and this pH is right around 12. It's actually probably a bit over 12. So what we can see is pH is over 12, we get a deep blue color. When the pH is low, we get a yellow color. And those are the two colors we see with this particular indicator. My next step is to take the absorbance spectrum of the low pH yellow solution and the high pH blue solution. Do you guys remember what an absorbance spectrum looks like with UV-Vis spectroscopy? It's how much light is absorbed at each wavelength. So the y-axis is the absorbance of the solution, the x-axis is the wavelength, and we're going to measure each wavelength. Our low pH solution is yellowish in color. So can you remember what that says about light that's able to be passing through it versus being absorbed? We're kind of expecting that the yellows are able to be transmitted, while sort of the opposite color, the purplish, is going to be absorbed. So you guys remember this setup. We've used the SpectraVis a couple times now in lab. And like I said, we are going to measure the spectrum, the UV-Vis absorbance spectrum of the two solutions. I've already blanked it with DI water, so I'm going to take that cuvette out. And we'll start with the low pH solution that has that yellowish color. I almost put it in sideways. So there's our spectrum of that low pH yellowish solution. We can see kind of what we expected, that it would be absorbing at the bluish and purplish wavelengths, and a lot of that yellow light is able to pass through. Looks like our peak wavelength here is at about 444 nanometers. Now we'll take the spectrum of the high pH blue solution. And this solution, also as we expect, is allowing the blues to transmit through the solution while absorbing the orange, red, and yellow wavelengths.